ideal gas law equation. Some more practice with that. Let's look at how we solve one more practice problem. If I have 7.7 moles of hydrogen gas at a pressure of 68.4 torr and at a temperature of 56 degrees Celsius, what is the volume of the container that the hydrogen gas is in? As always, I want to first list my givens. So up here, my givens, let's see. I've got a whole bunch of numbers up there, so I got to figure out what's what. So if you remember, I put up this thing last time. So first it says 7.7 moles. So I see moles goes with N. So N equals 7.7 moles. And that's the amount of stuff I have. And a pressure of 68.4 torr. So if I'm looking, okay, there's torr. So torr is for pressure, P. P equals 68.4 torr. Okay, what else? 56 degrees Celsius. So degrees Celsius is here. T, that's temperature then. 56 degrees Celsius. And what I want to do is get that into Kelvin though. So my equation there, I can take the Celsius plus 273. So 56 plus 273 equals, what's that, 329? Hope that's right. And lastly, what is the volume? But keep in mind there's an R value. So volume is my unknown. So I won't list the unknown. I won't write down the words unknown there. We just know that that's the unknown. So going back, remember, I've got to look at my R. So if I look at your R chart, there are two different values for R, 0.0821 and then 62.4. 0.0821 goes with atmospheres. So I look up at my pressure here, pressure's in torr. So I've got to use the 62.4 value. And I don't write, there's units there, but they're just going to cancel out, so I'm not going to worry about that. All right, so since I'm going to be doing some math here, what I'm going to do is switch to the drawing tool. Pencil. Okay, so write my equation out. It's always a good habit, starting from something that I know for sure to be true. And then I substitute in. One good practice, I think, that we didn't do in last class is to first solve for what we're looking for. And so some of you might decide, no, that's not going to work. But right now I've got V times P. If you don't want to work with symbols and you just prefer working with mostly numbers, then you may want to substitute next. But V times P, so those two are going to cancel there. So I'm left with this V equals nRT over P. So now I'll substitute it. N is 7.7. R 62.4. And this handwriting. And then T, I've got to use the kelvins. Okay, so if it's hard to read, these are the numbers from over here. Divided by pressure, so 68.4. Now it's just a calculator problem. And since my units for volume, they're going to be in liters. So I plug this into my calculator, this times this times this, hit equals, divide by 68.4, and I get what? 22, about 2,311 liters, which sounds like a lot, but turns out 68.4 torr is really, really low pressure, so that gas is going to be free to spread out a long ways. And 7.7 moles is actually quite a bit.